So now we'll see one more problem on bar graph. In the bar graph, we have seen the problem like there is a frequency distribution table is given, and in that case, we have to make the bar graph. But there are some types of problem in bar graph you will get where the bar graph is already given, and on the basis of that bar graph, you have to answer the question asked. So it is very important to understand the bar graph properly and accordingly answer the question. So we'll see one problem based on that. First, we'll make the bar graph, and accordingly, first we'll write down the questions. Then we'll try to solve the questions by understanding the bar graph. This is x and y axis. So accordingly, on the y axis, it is given oil production, oil production in millions, and on the x axis, it is given states. That is, state indicate the oil production in millions for the particular years. So data will be given on the basis of that. So first we'll make the bar graph. So as you are seeing there, we are making two bars which are attached to each other. So this two bar indicates the oil production of particular state in two different years. Like this blank bar indicates the oil production in the year 92-93, and this shaded bar will indicate the oil production for the year 93-94. So accordingly, this type of bars will also come where the oil production of two different years are given simultaneously attached to each other of the particular state. Like here also, for state UP, the oil production for two particular years are given. That is 92-93 and then 93-94. So accordingly, this will take this like whenever there is a blank bar, it indicates for the year 92-93, and whenever there is shaded bar like this, it will indicate for the year 93-94. So we will not write it again and again. So this is given for the state West Bengal, and accordingly we will make for one more state, and this is will take for the state Andhra Pradesh, and accordingly we will take 10, 20, 30, and till 100. So this data indicates the oil production in the particular states for two different years, 92, 93 and 93, 94. Now on the basis of that, we'll able to answer the question, whatever question will be asked. So first we'll see the first question, what is said in the first question. First question says, what information is given by this bar graph? So first question asks that what we are able to understand from this bar graph. So from the bar graph we can easily understand that the data given or the bar graph given is actually based on the oil production in millions of the particular states for two different years or for two consecutive years, that is 92-93 and 93-94. This is the information given by this bar graph. Now second question says which two states have same production in 93-94. So question asked is that which two states have the same production in 93-94. Now if you consider 93-94 means you will only have to look at the shaded bar graphs or shaded bars, because red bar indicates the oil production for the year 93-94. So it is asked which two states have the same production in 93-94. So as you can easily see from the bar graph that no two states are there which have the same production in the year 93-94. So answer will be no states are there. Accordingly, name the state having same production in both years. So in this question we have to tell that which state is there which has the same production in both the years. So as you can easily understand or easily see from the bar, that is UP is the only state which has the, so answer for this is UP. UP is the only state which has the same production in both the years, that is 92-93 and 93-94. Same production, because height of their bars is same for both the years. So accordingly we have to see those dead state. Dead state will be UP. So answer is UP. And accordingly we will see one more question based on this bar graph, like which state has minimum production. So in the question it is asked that which state has the minimum production. So if you consider both the years also, like 92, 93, 93, 94, in both the years the minimum production is there only in UP. So UP is the only state which has the minimum production in both the years. So accordingly, answer for this is again UP. And if let's say it is asked that which state has the maximum production. So if you consider both the years also, then Bihar is the only state which has the maximum production. So in that case, answer will be Bihar. So in this way, you have to understand the graph properly, and accordingly, you have to answer the question based on the graph. So this type of question will come in the bar graph. Either we have to make the bar graphs, or bar graph is given and we have to answer the question based on the bar graphs. So now we move on to the next graphical representation of numerical data, that is histogram. We have read about the bar graph. Now we'll read about the histogram. First, we'll understand what is histogram. See, histogram is also a similar type of graphical representation as that of bar graph, but histogram is a little bit different from bar graph in the way that there will be no spaces between the bars. Let's say if I make the histogram based on the given information. Most important thing here is that histogram can be made only for the data which is continuous or which having the class intervals. That means continuous or group frequency distribution table is given, then only we can make the histogram. For discrete frequency distribution table, we cannot make the histogram, because in histogram whenever we have to make the bars here, that bars will be connected to each other. Let's say in this type we have to make the bars in case of histogram. That is, bars are connected to each other. That is, there will be no spaces between the bars. So this is the main difference between the bar graph and histogram. Bar graph can be made both for discrete as well as continuous frequency distribution data, but histogram can be made only for the continuous frequency distribution data. It means like we have made this graph. Suppose let's say we have taken the class interval as 10 to 20, 20 to 30. So this point will indicate 10, this point will 20. Then next class interval will be taken as 20 to 30. Then definitely it will start from 20 and it will go up to 30, then 30 to 40, and then 40 to 50. So in this way, we have to represent this continuous data. So that's why the bars are connected with each other. That is, there is no spaces between the bars. So in this way, we have to make the histogram. And again, the bars which we are making again will be same, like that the class interval or discrete values, class intervals or discrete value, let's say observation, will be on x-axis, and frequency, or so we can take number of students like sometimes, or frequency will be taken on the y-axis. Then only we'll get the vertical bars. Otherwise, we'll get the horizontal bars. So in this way, we make the histogram. So for making the histogram, sometimes the data is given which data is given will not be in the proper continuous form. That is, proper continuous means like equal size class intervals are given, or you can say the class. Sometimes the data is given in the discrete form, or sometimes the data is given in the inclusive form. So accordingly, we have to convert those data into the exclusive form, or we have to convert those data into the continuous form to make the histogram. Because until and unless the data is in proper continuous form, we will not make the histogram. So first type of data we'll see in which continuous which in which we'll see continuous group frequency distribution, with equal class interval. So in this case, we'll see that equal class intervals or continuous group frequency distribution table is given with equal class intervals. In this case, we'll see how to make the histogram. So we'll see one example based on this. So accordingly, we'll understand how to make the histogram in the case when continuous frequency distribution table is given. Definitely we need continuous frequency distribution table, but with equal class interval is how to make the histogram in that case. So we'll see that example. So first we'll write down the problem. Then accordingly we'll see how to make the histogram. So this is given as weight in kgs and accordingly number of persons. So first we'll take the 50 to 55 class interval is given, and on the basis of that number of persons are given as 12. Then 55 to 60, accordingly number of persons are given as 8. 60 to 65, number of persons are given as 5. 65 to 70, number of persons are given as 4. 70 to 75, number of persons are given as 5, and accordingly we'll take one more class interval. 75 to 80, number of persons are given as 7. So in this example, it is given that class intervals are taken in the form of weights, like grouping of weights is done. Like 50 to 55 is the first group, 55 to 60, 60 to 65. In this way, groups have made of the weight, and accordingly number of persons between those weights are given. So this is the data given. So now as you can see, the class intervals is the weight and frequency is the number of persons. So accordingly we will take weights on the x-axis and number of persons on the y-axis. This is x-axis and y-axis. So now as the weight is starting from 50, it is not necessary that always the class interval will start from 0 or 10. It sometimes be the case that class intervals, like in this case, is starting from 50. So definitely we'll also start from 50 and we'll go up to 55, because the first class interval is 50 to 55. So in this case, you are seeing that the class interval or class size is same throughout. That is, class size is 5 throughout. So in this case, there will be no problem in making the histogram. We'll take the class size accordingly, like 50, 55, 55 to 60 in the same way as it is given. But as you can see, 50 to 55 is a difference of 5. But initially, as you know that x-axis and y-axis intersect at the point which is taken as 0. And between 0 to 50, there is a lot of difference, that is difference of 50 points. So accordingly, we will not take that much difference on the y-axis. To represent that difference, that large difference, we generally use this type of kink or this type of shape, which indicates that there is a greater difference between the 0 and the first point as compared to the class intervals or class size. This is known as the kink. We'll call it as kink. So now accordingly we start 50 to 55, then 55 to 60, then 60 to 65, 65 to 70, 70 to 75, and 75 to 80. So accordingly we have plotted the weight in kgs on x-axis, and now accordingly we will plot number of persons on y-axis. So accordingly we will take if you observe the data, it is 12, 8, 4, 5, 7. So accordingly we will take on the basis of that. So we will take the 0 to 2, 2 to 4. It will be easier for us to plot the points 8, 10 and 12. So now it is easier for us to plot the points. So for 50 to 55, the number of persons are 12. So accordingly we'll take this bar up to 12. So 50 to 55 indicates the number of persons 12 with the help of this bar or graph. 55 to 60 is taken as 8. So accordingly we'll take where is 8, and accordingly we'll make connect it, this bar with 50 to 55 and make it for 55 to 60. For 60 to 65 it is taken as 5. So 5, as we know, it comes between 4 to 6. So it is the middle value of 4 to 6. So accordingly we will take the middle value of 4 to 6 and it will represent the bar from 60 to 65. 65 to 70 is 4. So accordingly we will make it for 4. 70 to 75 it is for number of persons are 5. So again we will make it for 5. And 75 to 80 it is 7, which comes between 6 to 8. So in this way we have to make the bars, or we have to make the histogram on the basis of data given. So as you have seen here that the class size is same throughout, so definitely we need to take this width of the bars same throughout, because the class size is same. If the class size is different, then definitely this width will differ. But as the class size is same, so width should be same. So in this way we have to make the histogram on the basis of the information given. So this histogram we can easily make when the class size is equal, or class with equal class intervals are given. Equal class intervals are given, that there will be no problem. We have to take the bars of equal width, and accordingly we'll plot the class intervals with corresponds to the number of frequencies given. So this way we have to make the bars. But sometimes it is given that the class intervals cannot be equal, or class intervals given are unequal. So we'll see how to plot the histogram in that case, like continuous group frequency with unequal class intervals. So in this case, continuous group frequency is given, definitely we need continuous, but with unequal class intervals. So with unequal class intervals are given, so definitely if the class intervals is different, then definitely the width between the width of the bars is different. So how to make the histogram in that case? See, we'll understand this with the help of example. So directly we'll take one example. On the basis of that, we'll understand how to make the histogram in this case. So in this the data is given. Let's take weekly wages and accordingly number of workers. Weekly wages and number of workers. So weekly wages, let's take we'll group it as 10 to 15. Number of workers are 7. 15 to 20. Number of workers are 9. 20 to 25. Number of workers are 8. 25 to 30. Number of workers are 5. 30 to 40. Number of workers are 12. 40 to 60. Number of workers are again 12. and then we'll take it for one more class interval, that is from 60 to 80. Number of workers are 8. So this is data is given as weekly wages, that is how much wages the workers will get in the week, that is weekly wages, that is and it is taken in the form of groups, that is 10 to 15, 15 to 20. In this way the group is made, and accordingly number of workers are defined in that group. So now here you can see that class interval is different. So initially 10 to 15, 15 to 20, 20 to 25 and 25 to 30. Class intervals or class size in this initial four uh, groups is 5, but after this 30 to 40 class size is different, that is 10. 40 to 60 class size is different, that is 20. Again for 60 to 80 it is again 20. So class interval or class size is different. So in this case what we have to do, we actually have to find out the adjusted frequency. We actually have to find out the adjusted frequency if the class interval or class size is different. If class size is not different, then definitely we will make the graph as we have made in the previous example. We have to make the graph in that way. But if the class size is different, then definitely we need to find out the adjusted frequency. And how to find out the adjusted frequency is, there is a formula for that, that is small h divided by class size multiply by frequency of class, where h indicates the minimum class size. So value of h is same throughout, because minimum class size will be same throughout. As you can see in this example, minimum class size is 5, because there are different class size, that is of 5, 10, 20. But the minimum class size is 5, so definitely in this case h will be equal to 5, which is same throughout. Now h divided by class size, and class size indicates the class size of the particular class. Like if you have taken the class as 25 to 30, and class size in that case is 5. If you have taken the class as 40 to 60, so class size in that case will be 20. So that will differ accordingly which class we are taking. Multiply the frequency of class. Frequency of class indicates the frequency of the particular class. Like suppose if you are taking the class as 20 to 25, in that case the frequency is 8 in the particular example. Now if you have taken the class as 60 to 80, in that case the frequency is 8 again. So accordingly which class we are taking, so we have to take the frequency of class accordingly. So now we'll see how to find out the adjusted frequency. So if we see how to take the adjusted frequency, we'll again make the one more column in this which indicates the adjusted frequency. So first it is definitely weekly wages. Next, second we have taken as number of workers, and third we'll take it as adjusted frequency, because we need to find out the adjusted frequency in each case. So as weekly wages is taken as 10 to 15, in that case the number of workers are 7. So accordingly we will have to find out the adjusted frequency for this particular class. So adjusted frequency in this case will be, as you can see, h, that is 5 for 10 to 15. Adjusted frequency as h is 5 divided by the class size. Class size here is 5 for 10 to 15. Multiply the frequency. Frequency in this case is 7. So adjusted frequency will remain the same as 7. Now if we take the class size, class interval as 15 to 20, again the frequency here is 9. So adjusted frequency will again be same, because class size in this case is same as that of the minimum class size. If the class size of the particular class is same as that of the minimum class size, then adjusted frequency will remain the same as that of the frequency. So class size here is again same. Now if we take the next class as 20 to 25, again the class size is same as that of the minimum class size. So adjusted frequency is same as that of the frequency, that is 8. Now if we take it as 25 to 30, so class size is again same as that of minimum class size. So frequency is 5, so therefore adjusted frequency is also 5. Now next case, like next class is 30 to 40. Now class size here is different as that of the minimum class size. So if we have taken as class interval 30 to 40, in this case we need to find out the adjusted frequency for 30 to 40, that is equal to minimum class size, that is 5, divided by the class size of the particular class, which is equal to 10, multiply frequency of the class. Now frequency of this class, that is 30 to 40, is 12. So now we'll solve it, we'll get as 5 by 10 into 12, that is we'll get as 6. In this case the adjusted frequency has changed now and it will become 6. Adjusted frequency has become 6. Now again if we'll take it as 40 to 60, we'll take it at 40 to 60. Again here you can see that the class size is different as that of the minimum class size. So what we have to do in this case is again we have to find out the adjusted frequency, which is equal to for the class 40 to 60, which is equal to minimum class size, that is 5, divided by class size of the particular class, which is equal to 20, into frequency of the particular class, which is equal to 12. That is for 40 to 60 frequency is 12. So if we solve it, what we'll get the adjusted frequency as 3. So in this case, the frequency, again the adjusted frequency is different from the frequency, that is 3. And in the same way, we have to find out the adjusted frequency for 60 to 80. So it will come at around, that is again will be equal to 5 by 20 into 8. So it will come around 2. So adjusted frequency in this case again different from the frequency. Now we have to plot the graph for the weekly wages and the adjusted frequency. That is, weekly wages will be taken on the x-axis and adjusted frequency will be taken on the y-axis. We don't have to plot the graph for the weekly wages corresponds to the frequency, because if we make the graph for the weekly wages correspond to the frequency, there will be no use of taking the adjusted frequency and that graph will be wrong, because as you have seen here that the class size is different. So if the class size is different, we need to find out the adjusted frequency and accordingly we have to make the graph for the class intervals corresponds to the adjusted frequency. Now we'll see how to make the graph for the adjusted frequency. So x-axis consists of weekly wages and this y-axis consists of adjusted frequency. Now we'll take the class interval as it is given, that is 10 to 15. Class interval will be taken as same, which is given, that is 10 to 15, 15 to 20, 20 to 25, 25 to 30. As class size is same till now, so that's why we have taken the same gaps between the class intervals, that is 10 to 15, gap between the 10 to 15 is the same as that of the 20, 20 to 25 and 25 to 30. But 30 to 40 class is different. So the gap which we have taken up till now, that is as the class size was 5, so we have taken the gap. So accordingly, if the class size is 10 now, that is double of the class size of the previous class size. So accordingly, we have to take the double the gap. That is gap which we have taken between 20 to 25 to 30. So that gap will be doubled for 30 to 40. So accordingly we have to take the double gap, that is 30 to 40. Now 40 to 60 is again double that of 30 to 40. So again we have to take the doubled gap of 30 to 40, that is for 40 to 60, and again for 60 to 80 it will be same as that of the 40 to 60. This thing we have to keep in mind for plotting the graph in this particular case when the class size is different. Now for the 10 to 15, accordingly we have to plot the adjusted frequency. So first we'll take the adjusted frequency on the basis of that 2, 4, 6, 8, 10. So this we have taken the adjusted frequency. For 10 to 15 adjusted frequency is 7. So accordingly we'll plot it for 7. For 15 to 20 it is 9. So accordingly we'll plot it for 9. For 20 to 25 it is 8. So we'll take it at for 8. 25 to 30 it is 5. 5 will come between 4 to 6. Now for 30 to 40 adjusted frequency is 6. So accordingly we will plot it for 6. For 40 to 60 it is 3. And for 60 to 80 it is 2. So in this way we have to make the histogram in the case when the class size is different, and we have to make plot the graph of this class intervals corresponds to the adjusted frequency. Now in this case the as you can see the width of the bars is different. Why it is different? Because the class size is different. That's why the width of the bars is different. So in this case, definitely width will be different, because if we are taking the width, if we are like showing the width same in this case, then the graph will be wrong, because the class size is different. So definitely the width of the bars should be different. So in this way, the graph should be made for when the class size is different corresponds to the adjusted frequency.